This is a hi students. Once look at the background videos to understand the distance and the displacement. What is the distance and the displacement? Okay, here I will give some example. Then you can understand better what is the distance and the displacement. Distance means the total length covered by a body in a given time. The total length covered by a body during motion is called distance. Okay, now. Distance is the total length. Displacement is the shortest length between initial point and final point. Initial point and final point. Look at here. Example 1. Distance is nothing but total length. Total length of the path during the motion. Total length of the path during the motion. Here, the body started from the point A. Point A. So, body is moving like this direction, and it reaches the point B again after moving in this direction. It is the finally it reaches the point C. From the distance A to B, 4 meters given. From the distance B to C, 3 meters given. What is the distance in this case? So here distance is the total length of the path. Total length of the path. So here distance is the 4 meters plus AB plus BC. AB plus BC. 4 meters plus 3 meters. Here distance is the 7 meters. Distance is the 7 meters. Total length. Distance means total length covered by a body during the motion. During the motion. Okay, now. So during the journey, here the body covered the distance of 4 meters plus 3 meters. It is the distance. What is the displacement? Okay, now displacement means irrespective of the shape of the path. Okay, now don't neglect the shape of the path. When you join the initial line to the final point from the joint, when you direct the line segment from initial point to final point, it gives the displacement. Okay, now so displacement is nothing but the shortest path between initial point and final point. So here A is the initial point. Okay, now next C is the final point. When you join the line joining from initial point to final point, it gives the displacement. So when you closely observe here, it is a right angle triangle. So here this hypotenuse gives the displacement of a body. So here AC is the displacement of a body. We know that it is a root 4 square plus 3 square. It is a root 25. It is the answer is a 5. So here displacement of a body is a 5 meters. Okay, now displacement means shortest path between initial position and the final position. Okay, now when you closely observe here, distance is a scalar quantity. It doesn't have any direction. But when you look at here, displacement is it has a both magnitude as well as a direction. When you closely observe here, distance is 7 meters, displacement is 5 meters. So distance always greater than or equal to displacement. Distance always greater than or equal to displacement. So distance means the total length during the motion. The total length of a body during the motion is called distance. Displacement means when you join the initial line and the final point. Okay, you neglect the shape of the path. When you join the initial position and the final position, it gives the displacement of a body. Look at here. In this case, a body is moving from A to B. Here it is the body position is a half circle, half revolution. A body completes half revolution. What is the distance? Half revolution means circumference equal to 2 pi by 2 pi r. Half revolution means by 2. So here distance equal to pi r. Distance is a pi r. When a body completes half revolution, so here the body moves from here to here, distance is a pi r. Distance is a pi r. What is the displacement? Here, displacement is a when you join the initial point and final point. Here, when you join the initial point and final point, it gives the displacement of a body. So here it is the, in this case, displacement is the diameter of a circle. A body moving in a circular path, it completes half revolution. Half revolution complete cheste body distance and the 2 pi r by 2. Okay, na total circumference is the 2 pi r. Half means by 2. Here distance is a pi r. Distance is the pi r. What is the displacement when you join the initial point and final point? Initial point, final point join cheste, it gives the displacement of a body. This gives the direction of a displacement of a body. Okay, in this case, displacement is a AB is a displacement. AB is the diameter of a circle. So here it is a R, here it is a R. Here displacement is a 2R. In this case, displacement of a body is a 2R. R plus R, 2R. 2R is the displacement of a body. Next, if a body completes a full circle, if a body completes one revolution, okay, now starting position is A. A is the starting position. Okay, now finally it comes to the position A. Okay, it completes one revolution. The body completes one revolution, starting from A, and finally it reaches the point, same point A. So in this case, what is the distance? So here distance is the 2 pi r. Distance is the 2 pi r. Distance is the circumference of a circle. It is the 2 pi r. What is the displacement? When you closely observe here, starting point this, and finally the body comes to the same point. So here initial point and final point are same. So in this case, displacement is a 0. In this case, displacement is a 0. Same example, when I throw a body vertically opposed to a 50 meters height or 20 meters height, here is a base. From the base, I throw a object 20 meters upwards. So it is moved to the 20 meters upward, and finally it reaches the same point. What is the distance and what is the displacement? So distance is nothing but we have to add the total length. 20 plus 20, here distance is the 40 meters. What is the displacement? Here displacement is a starting position is this and final position also same. Okay, so here displacement is a 0. Here starting position or final position are same. Displacement is a 0. Distance is a 40. So distance always greater than or equal to displacement. Always greater than or equal to displacement. Let's look at here. When a body completes a 1/4 circle, here a body is starting from position here and comes to position here. A body completes a 1/4 circle. What is the distance and what is the displacement? Look at here. This is the circle. Body completes 1/4 revolution. So here it is R. Look at here. Distance is 1/4. 1/4 of the circumference of a circle. So here, okay, now pi r by 2. Pi r by 2 is the distance traveled by a body. What is the displacement? When you join the initial position and the final position, it gives the displacement of a body. So here it is the, when you apply Pythagoras theorem, r square plus r square root 2r. So root 2r is the displacement of a body in this case. Next, by using the coordinate system, look at here. The position of a body is changing from different places. A body starts from O and moves to the point Q. After that, a particle moves to the point P. Okay, now what is the distance and what is the displacement? Look at here, displacement from O to P. Here the body position is the here. Next it comes to the position here, P point. What is the displacement? What is the displacement in this case? So displacement is nothing but delta x equal to formula x2 minus x1. Delta x equal to formula x2 minus x1. x2 is the final position of a body. x1 is the initial position of a body. So here final position is a 360, initial position is a 0. So 360 minus 0, here 360 meters is a displacement of a body when it is moving from O to P. When it is moving from O to P. Next thing is find the displacement of a body from P to Q. Okay, and if a body moving from O to P and P, it returns from P to Q. What is the displacement when a body moves from P to Q? Here also same formula, displacement delta x equal to x2 minus x1. Here final position is a 240 minus starting position is a 360. Here minus 120 meters is a displacement of a body. Minus 120 meters is a displacement of a body. So in this case, displacement is a negative, minus 120. Okay, in this case, displacement is a 0. In this case, displacement is a positive. So distance always positive, but displacement may be positive, may be 0, may be negative. May be positive, may be negative, may be 0 displacement. So displacement is a vector. Displacement is a vector. So it is a direct line joined from initial point to the final position. Okay, now distance always greater than or equal to displacement. Next other case is there. Look at here. I will explain one different cases. When a body moves in a circumference of a circle, okay, now it completes some length of the arc. It completes some length of the arc. Here, next application, very important application. This is a circle. When a body moves in a circular path, it completes some arc of a length. The position of the body is the starting position E, P, and after some time it reaches a point Q. After some time it reaches a point Q. What is the here it is not a, we can take for example it completes the position P. Okay, the body starting position is a P. Okay, now or we can take it as the body starting position is a P, and after some time it reaches the point Q. Okay, now this is the length of the path traveled by the body. This is the length of the path traveled by the body. What is the distance as well as what is the displacement? Look at here, this is position. Okay, now the position of a particle, it makes some angle at the center. At the position go, it makes some angle at the center. This angle is we can take as a theta. Theta is a subtended angle at the center of a particle. Look at here. In this case, the body moving from point to P to Q. What is the distance and what is the displacement? Here, distance is a arc length. Distance is a arc length. We can take as a S. So here, angle theta equal to arc length by radius. So here, arc length S by radius vector R bar. Radius vector R bar. Look at here, arc length S equal to R theta. Arc length S equal to R theta. This is the distance of a body. This is the arc length is the distance of a body. Next thing is what is the displacement? Okay, now when you join the direct line segment from initial point to the final point, this gives a displacement of a body. Here, displacement of a body is 2r sin theta by 2. Displacement of a body is 2r sin theta by 2. Okay, now put in the comment box how this formula came. Okay, now this formula has a little bit some derivation is there. You have to find the derivation and comment the derivation in the comment box. Okay, now when a body moves in a covers some arc in a circular path, displacement of a body is a 2r sin theta by 2. 2r sin theta by 2. If they will give angle, and radius. For example, if a body covers some arc length, okay, right, it makes a subtended angle 60 degrees at the center or 60 degrees at the center. Here theta given the 60 degrees. What is the displacement? Here radius of the circular path 30 meters given. What is the distance and what is the displacement? Now put in the formula. Displacement here, displacement equal to 2r sin theta by 2. 2 into 30 into sin 60 by 2. So sin 60 by 2 is nothing but a sin 30. Sin 60 by 2 is nothing but a sin 30. Sin 30 is a 1 by 2. Value is a 1 by 2. So here it will become 2 into 30 into 1 by 2. 2 cancel. Answer is a displacement of a body is a 30 meters. Displacement of a body is a 30 meters. If a body covers some arc length theta, they will given that 60 degrees. In this case, what is the arc length, what is the distance as well as what is the displacement. This is all about distance and displacement in the different cases. Okay, now this is when a body moves from A to B and B to C. What is the distance? Distance is the 7 meters, displacement is the 5 meters. Look at here, when a body completes half revolution, distance is a pi r. Displacement is a 2r. Direct line segment from B to A to B. When a body completes a full revolution, distance is a 2 pi r. Circumference of a circle, displacement is a 0. In this case, displacement is a 0. Next, when a body completes 1 by 4th revolution, distance is a pi r by 2, displacement is a root 2r. Next, when a body, okay, starting from position here, vertically upwards, and returns the same path, displacement is a 0. When a body covers some arc length, distance equal to r theta, displacement equal to 2r sin theta by 2. Okay, at the end of the video, I will attach the worksheet problems. You can solve the worksheet problems. Comment the answers in the comment box. Please like my video, subscribe it, share to your friends. Thank you. Hi students, in previous class we discussed about distance and displacement. Distance is a scalar, displacement is a vector. Okay, now difference I forgot to discuss about difference between distance and displacement. Here I will write okay, now here distance, difference between distance and displacement. You can pause the video and note the distance, difference between distance and displacement. Okay, now before watching this video, once look at the videos in the background. It tells about the speed in different cases. Okay, now look at the videos in the background. You can understand the example of a speed. Okay, now look at here difference between distance and displacement. Here distance is it is a scalar quantity. Displacement is a vector. It has both magnitude and direction. Distance always positive. Displacement may be positive, may be negative, may be 0. Okay, displacement positive ఉంటుంది, negative ఉంటుంది, and 0 ఉంటుంది. Next, here distance always greater than or equal to displacement. Distance always greater than or equal to displacement. Always greater than or equal to displacement. Next, both distance and displacement measured in meters. So SI unit is a meter. In both cases, SI unit is a meter. Here also SI unit is a meter. CGS unit is a centimeter. CGS unit is a centimeter. Centimeter. CM is a centimeter. Next, distance is it does not depend on the path. Distance is a path dependent. Distance is a path dependent. Distance is a path dependent. Here is a displacement is a path independent. So it does not depend on the path. Path